here's what I know. Dirty electricity is real, it's measurable, and you can have a lot of it or you can filter it. Are some people susceptible and sensitive to that? I think some probably are.
This is EnergyCast, and I'm Jay Dowenhower. Today we're talking about literally making cleaner electricity. The Department of Energy says almost a quarter of homes, on average, get unusable power. My guest says that's why our appliances and devices get hot. He has developed equipment for cleaning up this dirty electricity before it passes your meter. He also says it's the harmonics and distortion, two components of an electrical signal that are leading to all this wasted power and waste heat. Clean out that interference and none of your devices should ever get hot. That's the way they were designed, to always stay cool. My guest also says as we've gotten greener, electricity has gotten less cleaner. That's mainly due to all the energy being generated and charged with direct current. We don't get our energy from DC, that's AC, but all the solar panels have to run through an inverter from DC to AC, and all our battery-powered devices have to be inverted back to DC. There's a lot of opportunities there for harmonics to get out of whack. It's a bit controversial, but my guest says he's witnessed firsthand the effects of these bad signals on people's health. He believes his products have made these people better. One condition he references is EHS, or electromagnetic hypersensitivity disorder. This condition has probably been most famously portrayed by Michael McKean's character on Better Call Saul.
Hey, sir, you can't do that. All of this needs to stay on.
No electricity. You understand?
Sir, I need you to get down from there.
What the hell kind of torture chamber you running here? He's allergic to electricity.
You heard the doc. Get down now.
All these lights and machines, you might as well throw them into a microwave.
Come on down now.
Don't touch me.
This condition is still not fully understood. The World Health Organization is undecided on a definitive cause for the symptoms EHS patients exhibit. In the scene I just played, the doctor later secretly turns on one of the devices on the hospital bed. It goes unnoticed.
That was a dirty trick.
That wasn't a trick. It was a demonstration. This allergy to electricity isn't real. It's a manifestation of something deeper.
I'm not saying it's 100% real, okay? But Chuck is smarter than you and me put together. So we're not talking him out of this. And I'm not sending him to a rubber room.
My guest says he's run blind tests on folks he's sold products to, and they can tell if the power signal's being filtered. It's a fascinating topic that should be compelling to anyone who wants to know about both personal health and greater energy efficiency. My guest today is B.D. Erickson, CEO of Satic USA, a clean electricity company based in Missoula, Montana. The company has been operating over 12 years. They build filtering devices for homes, industrial, and commercial facilities. In fact, they think the results are even better for buildings that need higher voltages. Satic also operates one of the largest, if not the largest, residential solar businesses in the state. He says if you have panels on your house, you need to give him a call. We also take a deep dive into Better Call Saul and the health issues he's witnessed firsthand. I hope you enjoy my conversation with B.D. Erickson. We're here with B.D. Erickson, CEO of Satic USA. And B.D., look, when it comes to energy technologies, this is the one that I would lump into the other category. So how are you literally making clean electricity?
I grew up in a solar manufacturing family. Growing up in Western Montana, we had a solar panel manufacturing facility. Solar and clean power has been something that's been in my sphere for the majority of my life. And one of the maybe misconceptions or confusing aspects is that solar energy is green. Is it clean? Well, it's clean, Jay, in that it's renewable. It's not coming from coal. It's not coming from fossil fuels. However, the electricity actually produced by the inverter by other standards would not be considered clean. See, alternating current has some attributes. It's got voltage, wattage, amperage, but it's got harmonics, distortion, interference, power factor, frequency, these other things. And oftentimes the electricity made from renewable energy sources has some of those factors factors that are outside of an acceptable tolerance.
Give us some examples of dirty electricity. You mentioned solar electricity. Solar's direct current. It needs an inverter to be turned to AC, alternating current, which we all use. But what is an example of dirty electricity, this issue with the harmonics, as you put it?
Yeah, you bet. The volts and the amps and the watts, we want those within a parameter, like we want 120 volts. But is there a parameter for electromagnetic fields, interference, or distortion? Well, there's guidelines, but here's an example in your or my life where we've experienced dirty electricity, but we didn't know that dirty electricity was the culprit or the cause. You're charging your phone, and this time it's really hot. It didn't get hot the last 20 times, but it is today. You walk up to your DVR, and it's really toasty warm. The back of your TV's warm. Back of your fridge is really warm. So what it is it's fuzz. It's harmonics or distortion, extra waves on that electrical signal that really only wants one wave. It wants one primary frequency at 60 hertz. And what happens from the culprits, it adds more distortion and interference. The result of that, maybe you see it on the TV with fuzzy lines. Maybe you hear a click or a pop or a tick in your speakers, and none of that ideally should be there. Now, 20 years ago, 30 years ago, was dirty electricity real? Well, it was a lot less. We used incandescent light bulbs. Those actually cleaned electricity. They're a resistor. They would just turn the dirty electricity that we're talking about, electromagnetic fields, harmonics, interference, distortion, into heat. So it cleaned them. So electricity was, for the most part, clean. But then, about 20 years ago, we started using the curly Q light bulb, the compact fluorescent light. Those are not electricity cleaners. Those are electricity dirtiers. It got worse. We all got all these DC devices. Well, we live in an AC world, alternating current, but your tablet, your phone, your laptop, anything with a battery is direct current. They too further distort and harm the electricity. Then we've got all this great renewable energy, and I love renewable energy, but we're taking a DC panel and we're using an inverter to create this alternating current. And just because of the change in our world, electricity is dirtier today than it's ever been. And I'm here to tell you, dirty electricity is real, it's measurable, it's wasteful, and now they're beginning to prove bad for you and I, the biological.
How often is this an issue? Is all electricity a bad signal now?
That's a great question. So we live in America. We got the cleanest, cheapest power on the planet. And when it leaves the hydro dam, when it leaves the coal plant, it's clean. It's in good phase quality. It has good power factor, and it's pretty distortion free. Well, how many car washes and beauty schools does that electricity go by before it gets to your house? And so it gets so dirty along the way, they actually boost the quality and try and filter it at substations. By the time it gets to your neighborhood, though, when we go into a home with dirty electricity meters, these 3 brands of meter that we use, the numbers should be 100 or less. We see them 500, 600. Now, if you have solar, and I'm not bashing solar, but if you have an inverter, then you're going to have 10 to 20x that number. So your answer is, it is clean when it leaves the dam, but by the time it reaches you or me, yes, it's dirty. It is dirty to a point that you really need to start thinking about filtering it for the life of your equipment and for the health of the people that you care about.
Yeah, you mentioned earlier back in the old days where your appliances would get hot. I'm, I guess, what you'd call an ex-millennial. So I was probably one of the last people to remember a black and white TV, a rotary phone. And yeah, I remember things getting hot in the day. How would you know if electrically powered appliances are being aged prematurely by this? Or is that just the normal wear and tear?
Dirty electricity is not something that maybe is on the top of everyone's mind. It's not something that they've necessarily heard about. But those common things like you just talked about, the back of your fridge being hot, it really shouldn't be. Your DVR and your TV, forget it. They're always hot because they don't have a mechanism for getting rid of this dirty electricity. So what they do is they simply convert that into heat. Now, that has a couple of bad results. Number one, electronics don't want to be hot. It's not good for them. They're not going to last longer. And your air conditioner is buzzing to beat the band right now. It's really trying to do its job of getting the home nice and cool. But you have now all these BTU creating devices in your home, which make the home warmer, which cause your electrical bill also to go up because number one, heat is not free. The wasted energy in those devices, you're paying money to make your stuff hot. That's number one. And then number two, you are now trying to cool your home to make it a more livable place. It's small gains, but it's measurable. It's noticeable. And then we add the component now of it being potentially bad for you.
And BD, if the harmonics are bad, if you had a motor and the harmonics were bad, the phases wouldn't be running harmoniously, right? It would almost be like the motor's kind of fighting against itself. Am I right?
Yes. When all the power is not usable, that extra power turns into heat. According to the Department of Energy, the average person right now is getting 77% real usable power. They're getting 23% on average reactive non-usable power. That's too much. And the result from that now is hot stuff. So do you really want to spend 23% of your bill making your crap hot? No. And so how do you correct it? You use a filter. And the result is you need less because it's all doing work and it's not being converted into heat.
You offer up some products here, mainly for homeowners. Units that can be installed near the breaker box. Looks like you have some LED light bulbs. You were talking about incandescent ones. And even a unit that can plug into an outlet. Tell us a little bit about that. How'd you come to those solutions?
Thank you. So we make a full line of commercial, industrial, and residential. Most of our sales products are the residential, where just as you said, you can wire it at your panel. And now what's it do? It stops all the electricity that's entering your home and filters it. It cleans it, it filters it, regulates it. So your phone charges cool and fast. Your DVR is cool, your power bill is down. And if there is a health component there that you're concerned about, you have that clean power. If you have solar now, you're getting better bang for the buck out of the solar. Your utility costs go down. And some people really believe that they can feel it. I don't suffer from it, but people that can feel it, they say they can feel it and they feel better. We also have plug-in units. And the fun thing about these products, you don't have to wait to know if it's working. We have meters, we sell meters, we lend meters, you can buy other meters online. And when you plug them in, you can immediately see EMF go down, interference go down, distortion go down. And if you have an amp meter at your panel, you could actually measure the amps if you wanted to at your panel and see it go down. You know it's working the moment that you install it, and it's guaranteed to work or your money back.
Yeah, and BD, just listening to you, I mean, this idea that you were bringing up that 23% of the electricity may be inefficient and waste heat. Have you approached anybody about solutions a little bit further up the chain? I worked in transmission. We were dealing with some high voltages. I know there was some equipment to help with the harmonics down the line, but do you think this should be taken care of higher up the voltage chain?
You know, that's a great question. Let's say that you and I are going to filter a river. You really wouldn't go up to the top of the river where the snow is melting. The farther down you get, that's where the pollution starts. I really don't blame the utility. They're delivering, at least to the substation for your neighborhood, pretty clean power. And you're right, they do. They filter it.
If you want to try to keep that 23% from being lost, does that now make that 23% usable?
Great question. It really does. We don't get you to 100%. We get you to about 95. It makes your day, it doesn't make your life, but it's measurable. It's a very robust surge protector. And most of the units that we sell these days, believe it or not, are really for health because people have someone in the family that is sensitive or they're autistic or they're having trouble sleeping or something. And if this can relieve that at all, then it's worth it. And if you save on your bill as well, and so the product's able to pay for itself over the next year or two and you get it for free, the last 2 years for our business have been incredible, beyond what we saw coming.
You mentioned you guys are involved in solar as well. Given what you've discussed, this idea that you've got to invert that direct current as soon as the sun hits it, this is something I've heard about in the past. The electrical output you get from solar farms is by its own nature variable. Aren't there systems in place to prevent that already? Where in electricity's journey from solar would you want to make that adjustment?
You're right about that. And I won't do it to you again, but we have these attributes. Solar has figured out most of them. The voltage is usually great. The primary frequency is usually great. And the power factor is usually great. It's these other things. It's the harmonics and distortion. And that's taking place really at the inverter. Solar just needs one more component. It needs a filter. And currently, we're one of the only companies on the market that makes something specifically to address that.
For rooftop or for commercial solar?
Both. Whenever you're about to put it on the panel, whenever you're about to feed it to the home or the facility, that's the place where we filter it.
After the inverter.
That's exactly correct. After the inverter. Yep. After the inverter, before your home or before your office.
Sure. And look, I know that voltage in particular is very important in industrial settings. Again, in my experience with transmission, I upgraded capacitors at customer-facing substations to help with voltage drops, right?
Sure.
The point being here, BD, is that machinery is extremely sensitive to electricity coming to it. Are you talking to those folks, big factories, places that are using a lot of big-time machinery, a lot of big motors running?
Absolutely. In fact, that's where the equipment really sinks. And a lot of times those facilities have a portion of their bill that's their demand charge. So when those big motors are really humming, when they first come on, they're really humming, the high watermark for the electricity sets a demand charge. And that demand charge is very high. And so when you can lower that total power and get that dirty electricity and that non-usable power, get that kVAR power and that harmonic power off there, man, you can really lower the demand charges. And so in residential, we're not billed for kVAR in residential. We're not billed for demand in residential. So the savings is quite low. In a facility like that, where you might be billed for kVAR, or maybe you're billed for power factor, or you're billed for demand, oh boy, now the savings get really exciting because now you might be looking at under 1 year ROI.
Right. And I'm curious, is it the same as a home where you're losing about a quarter of it, that 23%, or is it higher?
It's higher. And they might even be charging you for it. So you might get double dipped.
You know, one of the things I love doing is talking to a guest who's not from West Coast, East Coast, Montana, right? Pioneering technology like this. What's the story there?
So as stated, growing up in Western Montana, my family was part of a company called Sunwise Solar that made solar panels, and they were not photovoltaic. They were induction warm air, and you could heat your home. So it was on my mind. But then I started in the light bulb industry in my 30s, and I really saw the difference between a light bulb that made a lot of heat and a light bulb that made a lot of light. That's when I started to learn about dirty electricity. And then when I bought this house under the biggest power lines you've ever seen and the way that affected my son, it took me down a journey as a young man I never expected to go on. And so from there, it was the marriage of all the things that I learned and all the things that had been a part of my life that led me to the focal point of where I'm at now.
You mentioned the health issues. The big health issue that I was most curious about going into this interview, I talked to one of your folks who pitched this story. The first thing that came to mind, especially with the electromagnetic hypersensitivity, was that show Better Call Saul. Michael McKean's character, Saul's brother, allegedly suffers from EHS. And look, I'm saying allegedly because it didn't seem like the show took it very seriously. They had suggested that it might have been psychosomatic. There's a scene where one of the characters still has a cell phone on right next to him. He thinks that all the electronics are off. So there's a little bit of back and forth there. I looked at the WHO, what they had to say about EHS, and they were saying that, look, you know, we don't deny that people are having reactions and maybe rashes and stuff, but it could be something else. It might be responding to flickering fluorescent lights or something like that. So where do you come down on this? Are you trying to solve EHS, or is it bigger than that?
I think if 10 people have an illness, are one or two of those people maybe suffering from something else and being misdiagnosed? Probably. It's certainly conceivable for me. If 10 people have an illness, are one or two psychosomatic is in their brain? Sure, I don't have a problem with that. I don't think any of us do. I think we all realize that it could be coming from something else or it could be in their mind. But EHS patients are some of the most marginalized in the medical field. Now, I know for myself, 30 or 40 years ago, autism was quite rare, and we know it's exceedingly common now. I remember when fibromyalgia kind of hit the scene that we marginalized women with fibromyalgia, and now we know for a fact it's overactive nerves. I don't suffer from EHS, but there are sure a lot of folks that do, and our products seem to help them. Now, we do a fun game sometimes occasionally when a customer or patient is EHS, we'll have them turn their back and we'll plug the unit in or turn it on. And I'm telling you, a lot of them can feel it. They know the difference and they can get it right every time. I can't feel it, so I don't want to be disingenuous, but some people can. Is EHS a real thing? After 10 years in the business, I sure think it is. And do a lot of people genuinely suffer from it? I sure think they do. We know it's bad for equipment, and that's something I'll stand by and I feel good about. Here's what I know. Dirty electricity is real. It's measurable, and you can have a lot of it or you can filter it. Are some people susceptible and sensitive to that? I think some probably are. Not everybody, but we live in a world today where the electricity is dirtier than it's ever been. And oftentimes in society, there's a drastic change in that culture, like the aqueducts of Rome or asbestos, when a few years later, you find out that you didn't know maybe everything that you should have. But it's not because anybody was naughty. It's not because it was intentional or nefarious. I mean, the fact that we use a certain kind of light bulb and now we don't, well, that's not anybody's fault. Or the fact that now we have all these DC devices and, direct current is different than alternating current. So you have to clip that wave or strobe it. I don't think that's anybody's fault. I'm just stating that the way we use technology today results in current in a different way than it's ever been before. And we're not on the front trying to address that.
Yeah. You mentioned working with someone who said they had EHS and that they could tell a difference. I'd have to imagine that you've probably met several people like this being in this line of work.
Hundreds, Jay. Hundreds. Yes, it is so much more common than we had any idea.
Is there a group of people that organize?
There are tons. There are so many groups. There are so many smart Facebook pages and communities for EMF, people that believe that EMFs are bad for you, dirty electricity, the new 5G that's coming out. Right now, there are a lot of EHS support groups and EMF groups that want, at least for their living space, to have a clean EMF and dirty electricity free space, because whether it's in their brain or not, they're suffering.
Yeah, well, good point. Good point. All right, BD, I'm going to finish with the lightning round of your thoughts on different energy technologies, starting with natural gas.
Natural gas is really abundant. I live in western Montana, and eastern Montana has been fracking for oil for years, and they've got a lot of pushback on that. But what they have found are huge reserves of natural gas. The most important thing to BD's brain is when we discover natural gas to at least be able to capture and sequester it so that it's not just released into the atmosphere.
Crude oil.
We all were taught in fifth grade that crude oil is this finite thing that came from crushed dinosaurs and fossil fuels. I've heard things recently that say the earth might actually be producing more oil. What's the truth? I don't know. It certainly leaves room for renewables.
Nuclear.
Nuclear is very expensive to get going, but once you have the facility, you make a lot of clean power for years. And I think that nuclear power, because of some poorly managed facilities or natural disaster, has a worse name than it should have.
Yeah, they just call it nukes.
That's right.
Yeah. Coal. I'll add coal with carbon capture.
When you actually look at the amount of coal that's in the earth, coal could be used for a long time, but I don't think coal should be the go-to. I think it should be a holistic approach where coal has some maybe subsidies, some stuff, and has room. We've changed a lot of things. Crypto mining and computers and co-storage facilities and these huge server farms need a lot of power. Where's that power going to come from? I don't think solar panels is the only answer. Can coal play a role in that if it's managed cleanly? It sure seems like it could to me, because I think it can be part of a package.
You know who has the most coal of any other state in the country?
Montana's on the list.
Montana's number one.
Okay.
Doesn't mine the most. Wyoming does, but Montana has the most. Wind.
I won't pretend to be an expert in wind. It seems like the initial startup cost to wind is also very high. Wind is subject to nature. And so if the wind stops blowing, the turbines stop. That's what I'll say about that.
Solar.
Solar actually requires a little more natural resources in mining, I think, than some people realize. Now, I love solar. I think if people really knew, it's probably not as green as we think, but it's an interesting, renewable way to get power. It also creates a lot of jobs. The solar industry is one of the number one employers. It's a fast-growing sector. It's a good job, and it's a tech product that I think people love.
Biofuels.
I love biofuels. In Montana, the pine beetle has destroyed these big forests, and dead standing trees, man, they might burn. Why not collect those biofuels and take that to the coal facility where we want to keep that running? We want to keep those jobs, and then we replant that with native species living trees. If anybody would really get on board, there's something there.
Hydroelectric.
Hydroelectric is some of the cheapest, cleanest power on the planet, but what it does to native species fish and river systems is improper. I think that the dams that we already have, they're there. Nothing wrong with that power. It's cheap and it lasts a long time. I do not believe that new dams should be constructed because of their impact on native water systems.
Geothermal.
Geothermal is one of those things. It's expensive to get into, but we know the ground is always in the mid-50s. It's a lot easier to heat it from 50 to 80. It's a lot easier to cool it from 50. Kind of expensive to get into, but it seems pretty matter-of-fact and intelligent to me.
Energy storage.
That's the one. Of all the ones you've asked me, that's the guy. The big leaps right now are in energy storage because we talked about wind, we talked about solar that work when nature is playing along. The lithium, cobalt, metals that are mined is very hard on the planet. There are better energy technologies like flow batteries that are alkaline and acidic that don't take all those precious metals. And what happens over the next decade in energy storage, I think could have a bigger impact on natural resources and the planet than anything else you've talked about.
Electric vehicles.
I'm going to take this one on the chin, I'm sure. I think they cause more damage in mining the metals and materials that go into the batteries than they do save anything. For most people, when they plug their electric car in, they're charging it with electricity made from coal. While they're really fast and beautiful and really fun and sexy to drive, I don't think they benefit the environment the way they're being purported to.
Energy efficiency.
Energy efficiency is great. And this is the space that we come in. We're saying, don't stop using your phone. Don't let it get hot. Don't stop using your DVR. Don't waste electricity. Turn your lights off. Manage the thermostat. Leaving windows open and stuff. Maybe the lowest hanging fruit and the easiest way to get is through energy efficiency. And that's what Satic is all about. Our LEDs don't add distortion. Our insulation helps you keep the hot or the cold that you've made in. And our units help your equipment run on just the amount of the electricity that they need, not the most. I think that energy efficiency is an easy way to get there. We can all participate. We can teach our little kids to turn the lights off. And that's sure a lot easier than mothballing a coal plant. Turn some lights off, heaven's sakes.
And then finally, fusion powered.
So the white whale, I'm not an expert in the field. I've heard that hydrogen and fusion technologies and some other technologies are out there or exist. Won't it be exciting over the next 20 years if there's a breakthrough so that we can have a different viewpoint and discussion on all of the rapid fire questions you just asked me?
All right, BD Erickson, Satic USA, thank you so much for your time.
Thank you, Jay. It's really been a pleasure being here. I've really enjoyed it.
That was BD Erickson, CEO of Satic USA, a clean electricity electronics manufacturer. I want to thank BD for his time as well as Dylan Smith at Satic for setting this up. You can find plenty of pictures for this episode on energy-cast.com as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 109. Be sure to join us next week when I host a panel on how we're extending the life of our nuclear, renewable, and fossil generation. Until then, I'm Jay Dowenhauer. We'll see you next time.